Okay, so hello everyone. My name is Nadav, but I'm better known online as Shesek. I'm an ambassador at the Tel Aviv Bitcoin Embassy, which is a non-profit community center run by volunteers for the promotion of Bitcoin in Israel. It is a physical meeting place that's open all week long, and we also organize all sorts of events like meetups, hackathons, and workshops. Okay. I'm also the founder of Bitrated, a service that provides buyer protection for Bitcoin payments using multi-signature, and also working as a contractor with Blockstream. Some of my work with Blockstream includes Explora, the open source block explorer powering Blockstream info, the Spark Lightning wallet, the Lightning Charge payment processing system, and the week of Laps, which was basically 7 Lightning applications, all built on top of Lightning Charge, that were released about a year ago, over a week, 1 application each day, each showing a different use case for Lightning micropayments. For today's talk, I'm going to show you Spark, Lightning Charge, and a few of the Laps that I built on top of it. I will be showing some technical details throughout the talk, but if that's not your thing, then feel free to just ignore it, and I will try to quickly move on to the more graphical stuff. Okay, so starting with Spark. Spark is a minimalistic wallet user interface for C Lightning. It is written using Cycle.js and Narix.js in JavaScript. Spark can be accessed using any web browser, including iOS Safari for the iPhone folks in the crowd, or using the mobile application for Android and the desktop applications for Linux, Windows, and Mac. The iOS application is not available yet, but should hopefully become available soon. One important thing to note about Spark is that it requires you to separately manage a C Lightning node, either on a computer at home or on the cloud, preferably at home, of course, where Spark basically acts as a remote control for using Lightning in day-to-day payments. So if you have some experience with the command line, setting up Spark should be relatively straightforward. It's basically just a matter of installing the package with npm, which might require sudo in some environments, and starting the Spark server daemon. And we will later see what the pairing URL argument is for. Spark can also be set up using Docker. The command here will start up Spark and connect it to your existing C Lightning node. If you don't have C Lightning running, you can also use this to start C Lightning and Spark and connect it to your existing Bitcoin Core node. And if you don't have anything at all, then you can use this to start Bitcoin Core and C Lightning and Spark and wire them all together and go from nothing to reckless very, very quickly. Note that this will start syncing a Bitcoin full node, which will take a lot of disk space and quite some time. Okay, so let's see how this looks like. Yes, we'll start by installing the package. This should only take a few moments. I already have C Lightning running. We can test this with Lightning CLI, get info. It's running at the default location, so I can just start up Spark. The pairing URL argument that I added here causes it to print the URL, including the randomly generated access key. So we can simply open this link in order to authenticate with the wallet and load it up. Okay, so this is the the home screen of Spark. Here we can see the payment history. We can click on a specific payment to show some more details about it. On the top, we have the 2 buttons for the 2 main actions in Spark or in any Lightning wallet really, which is pay and receive or request. On the bottom, we have the node link, which will take us to a page with some more information about the node, as well as channel management and an option to deposit funds, on-chain funds into the node. We will see this later. And here on the top right, we can see the wallet balance. Clicking it will change the display on it. And here we can request a new payment. We can enter an optional amount or leave it empty to leave it up to the sender. We can also change the display, the units here, so we can enter an amount in US dollars. But for now, let's keep it with a nice round Bitcoin amount. And this is an optional description which will be shown to the user making the payment. Okay, yeah, so here we have the Bolt 11 request and the QR code, which we need to share if we want someone to send us a payment. So this is pretty nice, but the way Spark is really meant to be used is from mobile on the road. So let's see how we can make this happen. Now, usually getting your phone and your computer at home to talk with each other is a bit challenging because of routers and NATs that are in the way. You have to set up port forwarding. If you don't have a static IP address, then you need a dynamic DNS solution to point at your changing IP address. And this adds some friction and complication to the setup. Luckily, Spark ships with a feature that makes this a bit easier using Tor hidden services. Now, Tor hidden services have a few different advantages here. The first, and I think the largest one for home users, is that you don't have to set up port forwarding. Everything is done with outbound connections into the Tor network. So you can accept connections without really accepting connections. It works kind of like magic for you. Those of you that had the chance to deal with routers and port forwarding, it's quite magical that it just works. Another thing is that the .onion hostname is static, so even if your IP changes, the hostname will always point at your server. And it also has some security benefits. First, because the .onion hostname commits to the public key of the server, so by just copying the hostname, if you have a reliable copy of the URL itself, for example on your phone, then you can know that you are talking with the right server, and you get protection against man-in-the-middle attacks without having to rely on the broken certificate authority system. Another security advantage is that it also authenticates the user. So you can't access the hidden service without knowing the .onion hostname in advance. So it's a sort of a key, the knowledge of the hostname. This means that even if a security vulnerability is found with Node.js or with Spark, an attacker simply won't be able to access the HTTP server in order to exploit it, which significantly improves our security. So to do this, all we have to do is start Spark with --onion. You don't need Tor pre-install on your machine for this to work. Spark will go and fetch the latest Tor version on its own. It should just work. Another thing that we can do is the pairing QR argument, which will show us the same information that we saw in the pairing URL, but in the form of a QR, which will make it possible to scan it for mobile. We will see it in a moment. And I will also add LN path to connect it to a different Lightning node, so we can test payment between the two, and also start it on a different port so that it won't conflict. Okay, so here we can see the .onion hostname that it created, and the QR code is printed directly into the terminal. Okay, and okay, so from the mobile, I can open. Okay, the screen sharing is a bit quirky. I might have to reset it a few times, but it should eventually work, hopefully. No? No. Okay. Yes, so after installing the Spark application from the Google Play Store, this is the first screen that you will get, the server settings screen. And here we can click the scan QR. Did it get? Oh, God dang it. We give this another try. Okay. So yes, in the server settings URL we have, okay, we have the scan QR button, which allows us, no, come on, okay, which allows us to scan the QR. This will read out the URL. Yeah, the screen sharing has some delay. Let's try maybe. Maybe we can switch to the camera here after all. Can we do it, or is it too late? Okay, wait, it's loaded up again. Let's see. Maybe.
So see if we can switch to the camera on the desk, because the idea was to share screen.
Okay,
but
it looks like it started working again. Hopefully. Yeah, the first connection sometimes takes some time with Tor. But after the pairing, it should become.
you have the cam if you want.
Mhm.
So the split screen is slowing down, so we are trying to switch to the second camera.
And maybe in the meanwhile, I can show some other features in Spark. So here I mentioned the footer link earlier. This takes us to a page that shows us the address of the node, which is the information that we need to share if we want someone to open a channel with us. We can also see all of the channels that we have open. We can click them to show some more details. The orange here on the left and right is the channel reserve. Here we can open a new channel. Okay. Yeah, so here we can open a new channel. We need the node URI that we want to open with. Here we can either add an amount or use fund maximum to use all the funds available. And we also have an option to deposit funds into the on-chain wallet. We get a URL. We can also switch to pay to Scriptash. It looks like it could be. Orbot is a bit quirky in general, and if the internet is not very good, then it's even quirkier. But I tested it a few times. It should hopefully work. Okay, so it might not work. We can also do this. Yes, we can also try making. Oh, it loaded. Okay. So I actually do have this working here, so I think it's better if we switch back. Yes. Okay, so request 500. I think not for now. Sorry. And so here we can try a payment. Scan from here and pay. Okay, some other features that are available in Spark is the theme switcher. Here on the bottom right, where it says dark, is the name of the theme. You can click it to change to a different one. There are quite a few, like over 15 different color schemes that you can choose from. Yeah, this is a nice one. Let's stick with this. And another feature, which is a sort of an secret Easter egg thing, is that if you click the version number on the bottom left, if you can see the the cursor, if I click it, it will open up expert mode, which does a few things. First, it unlocks two new menu items, logs and console. Logs will simply give us all of the logs that are as reported by C-Lightning. Okay, maybe do this here. Yes. So logs would give you all of the logs available by C-Lightning. Console will open up a page that you can use to input commands directly into the RPC server. And it will also add some debugging information throughout the app. So, for example, next to every payment, you will see the full JSON representation as returned by C-Lightning, which could be useful for developers working with this. Okay. So I lost internet connection. What? Sorry? Oh, they did. Okay, so I can't do present, but it looks like it's... Oh, I'm good. Okay. Okay, so this is all for...
Okay, for now.
Okay, good. So moving on to Lightning Charge. Lightning Charge is a payment processing system built on top of C-Lightning. It is written using Node.js. Lightning Charge provides a very simple HTTP REST API for creating invoices, checking their status, and getting real-time updates. The API is trying to optimize for developer friendliness and ease of integration. It should be very, very easy to use this to add Lightning payments into your existing apps and services. It provides quite a few different methods for getting real-time notifications for incoming payments, so you can pick whatever works best in your environment. It also provides some nice utility features like currency conversion, so you can quote invoices in fiat, attaching metadata to invoices, built-in checkout page, as well as some other cool stuff. It has client libraries available for Node.js and PHP, but if you're using a different language, then it's also quite easy to use the HTTP API directly without a library. Setting up Lightning Charge should also be quite easy and quite similar to Spark. Assuming you already have C-Lightning running and Node.js installed at an appropriate version, then it's again just a matter of installing the package and starting the daemon. The cookie file argument will cause Spark to generate a random access token and write it into this file so you can read it out in order to communicate with the API. You can also specify your own API token if you prefer that. But this is nicer, I think, with the cookie file. So some very quick examples of using the HTTP API, just as a demonstration of how simple it is. So the example here is a basic example of creating a new invoice with an amount denominated in millisatoshis. So in the example here, we'll create a new invoice for 10 satoshis, and the API will give us back the invoice in JSON. This is a bit of a more advanced example where we quote the amount in fiat and have Lightning Charge convert it to Bitcoin for us. We can also specify a description that will be shown to the user making the payment. And we can also attach metadata, which is basically a JSON object that we can use to associate arbitrary metadata with the invoice. Checking the status of the invoice is a matter of a simple GET request. It will give us back the full JSON representation of the invoice, but the thing we would usually care about is the status, which could be one of unpaid, paid, or expired. Now, instead of repeatedly checking the status every few seconds, we can also use long polling, which basically means that we send a request and the response will hang either until the payment is completed or until the timeout is reached. This allows us to give the user more instant feedback compared to having to check every few seconds. So there are quite a few different applications written on top of Lightning Charge. I obviously won't have time to show all of them, but let's start and see how many I can squeeze in before they kick me off the stage. Okay, so the first one is FileBazaar, which is a system for content creators that want to sell digital files like music, photos, or videos. FileBazaar has a very simple setup and very minimal configuration. You basically just prepare a directory with the files that you want to sell. You need to make a config file, which is basically this is the part that you have to set, the required part, and all of this is optional. So it's basically just the access token for Lightning Charge. Oh. What is this? Oh, very weird. Okay. Which is basically the access token for Lightning Charge, a random token secret for FileBazaar itself. This is generated for you using the FileBazaar init, and the default price for the file, which we can later override for specific files if we wanted to. And once we have that, we can simply run FileBazaar inside of the directory, and it will give us a web interface that lists all of the files available for sale, so users can browse them. FileBazaar will also generate a free preview. So for example, in the case of a PDF file, it will show you the first page. In the case of an audio file, it will give you the first 30 seconds for free. It will also show some the EXIF metadata with some useful information like the duration, the name of the artists, and so on. The description that we see here came from the configuration file that we saw earlier. It's here in Markdown. Again, optional. If you don't set it, nothing will show up. And we can click Pay to get an invoice. And that's it. We get full access to the file, immediate full access, and yes. I actually wanted to show another example in the case of an image file.
5 minutes, Nadav.
Okay. In the case of an image file, FileBazaar will pixelate the left half and add the preview text on top of it. And again, we can, it was not supposed to happen. Okay. I got disconnected again.
Okay,
Did something happen with the network?
Yeah, try to use this very quick if you can.
I think I can actually deal without internet.
Okay.
Should be okay.
Better.
Okay. Another application is Lightning Publisher, which is a WordPress plugin that allows content writers to charge users for content they're publishing on their blog. This is how it looks like from the management side. The plugin adds a new shortcode to WordPress, if paid, which basically sets the cutoff point. Anything below that will be available free of charge, and anything after that will require a payment of 2 euro cents in this example. This is how it looks like from the user perspective. He can read the beginning of the post, and if he wants to read the rest of it, he can. I think I might actually do need internet working. AX Hotels is not just that one?
The public Wi-Fi is having problems, so this should be the business one that should hopefully work better.
Okay.
So let's see if somebody is able to copy the password one. It's like hacking training. You have to.
Oh, I shouldn't have done that, right? It's just a habit.
Okay, it's good. This is OPSEC demonstration live.
Yes, it's not working because it's denominated in euros and it wants to ask Bitstamp for the exchange rate. So I tried connecting to. Oh. Loading.
So far, Nadav, you have the strongest
I have an
demo
issue on
effect
my
I've ever seen it.
Loading 3 dots and yes. It won't work if I click it here.
Oh, different OPSEC issue. There shouldn't be a password.
Shouldn't be, just
There's no security.
none.
I have no security.
Actually, if I just change it to not use fiat, and it should work, yeah.
Oh,
Pay
great
wallet,
workaround.
pay and full access. Okay, another, do I have?
Yeah, let's go for other 3 minutes.
Okay, so another cool one is pay-per-call, which allows API developers to charge users of their API on a pay-per-call basis. So this is an example Node.js app written with Express that sends out SMS messages using Twilio. We can send a post request to it with the phone number and the message that we want to send it. It will send out SMSs. Now, if you wanted to charge users of this API for every SMS they send, for example, €1 for each SMS, then with pay-per-call, this is basically all that we have to do. We need to install pay-per-call, initialize it with the URL and access token for Lightning Charge, and add it as a middleware. And it will make sure that the payment is made before allowing the request to move forward. This can also be used as a reverse proxy. If your application is not written with Node.js, you can also do this, so in the example here, we have an upstream server on port 4001 that provides API calls free of charge. And this command will start another HTTP server on port 4000, which will act as a proxy, as a reverse proxy, and will make sure that the payment is made before allowing the request to be forwarded into the real API. This allows you to add Lightning payments for APIs without the API server itself knowing anything about Lightning or payments. If pay, then this is written on top of pay-per-call. It uses pay-per-call internally, and it's basically a connector between Lightning payments and IFTTT. If this, then that. If people are not, for those not familiar with it, it's a service that allows you to hook up all sorts of events. So if this happens, then do this. This allows you to, if this happens, part to be a Lightning payment, and the do this part can be all sorts of different things, like opening locks, changing the lights, operating IoT devices, sending SMS, sending emails, all kind of different stuff. Maybe just one last one, the Nano Pos, very minimalistic point of sale system. We have been using this at the Tel Aviv Bitcoin Embassy for quite some time now. It's a self-service station. You basically just pick, it won't work because I don't have internet, obviously. Yeah, but you basically click it and you see the QR code and you can make the payment. And yeah, maybe I will just mention one last application, which is a plugin for Woocommerce. Woocommerce is a very popular e-commerce system. It's powering the Blockstream store, and the plugin basically adds Lightning as a payment method. So if you want to set up a store and accept Lightning, Woocommerce is a very nice solution. It works quite nice. And
thank you very much. A big applause for Nadav.